term ground fault circuit interrupter is no longer used in the National Electrical Code. The current term is ground fault circuit interrupter, GFCI. GFI, without the C, was commonly used in the past, but it is now considered outdated terminology. The NEC has consistently referred to these devices as GFCI since the 1975 edition. Most professionals in the electrical industry, including contractors, inspectors, and engineers, refer to these devices as GFCI. It is no longer considered proper to use the term GFI. It is correct to use the term GFCI on all power plants. This is in accordance with current code requirements and industry best practices. The NEC decision to use GFCI instead of GFI was to provide clarity and consistency within the code. The term circuit more accurately describes the function of the device, which is to protect circuits from ground faults. The term GFCI is an acronym, so it should not be written as GFCIs with an apostrophe. GFCIs are required by the NEC in many locations, such as bathrooms, kitchens, and outdoor areas. GFCIs help to prevent electrical shocks by tripping if they detect a difference in current between the hot and neutral conductors. Ground faults can occur when a live wire comes into contact with a grounded surface or a person. This can create a path for electricity to flow through the person's body, which can cause a severe electrical shock. A GFCI is designed to detect these ground faults and quickly cut off the power to the circuit, preventing or minimizing the severity of the shock. The GFCI constantly monitors the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through both wires should be equal. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral wires. The GFCI is designed to detect this imbalance, even if it's a very small amount, such as 5 milliamps. When the GFCI detects a current imbalance, it trips the circuit, cutting off the power. The tripping action is very fast, typically occurring within a fraction of a second, which is fast enough to prevent a serious electrical shock. GFCIs are designed with a test button that allows you to verify that the device is functioning properly. Pressing the test button simulates a ground fault, causing the GFCI to trip. It's recommended to test GFCIs monthly to ensure they are working correctly. If the GFCI doesn't trip when you press the test button, it should be replaced. GFCI receptacles are designed to be installed in place of standard electrical receptacles. They provide the same function as a standard receptacle, but with added protection of ground fault circuit interruption. GFCI circuit breakers are designed to be installed in an electrical panel in place of standard circuit breakers. They provide ground fault protection for the entire circuit they protect. GFCIs are required in many locations throughout a building. These locations are typically areas where there is a high risk of exposure to water or moisture. Examples include bathrooms, kitchens, laundry rooms, and outdoor areas. The specific requirements for GFCI protection are outlined in the National Electrical Code (NEC). The NEC is a set of standards that provides guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. The NEC specifies the locations where GFCI protection is required, as well as the types of devices that are acceptable for use. Ground fault protection is essential for electrical safety. GFCIs are a proven technology that can help to prevent electrical shocks and save lives. By understanding the function of GFCIs and the requirements for their installation, we can help to ensure that our homes and businesses are safe from electrical hazards. When installing a GFCI receptacle, follow the manufacturer's instructions carefully. Be sure to turn off the power to the circuit before beginning any work. Identify the hot, neutral, and ground wires. Connect the wires to the corresponding terminals on the GFCI receptacle. If the wiring is incorrect, the GFCI will not function properly. Once the wiring is complete, carefully install the GFCI receptacle into the electrical box. Secure the receptacle with screws. Restore power to the circuit and test the GFCI by pressing the test button. The GFCI should trip, indicating that it is functioning properly. If the GFCI does not trip, check the wiring and ensure that it is connected correctly. If you are not comfortable working with electricity, hire a qualified electrician to install the GFCI receptacle. Working with electricity can be dangerous, and it's important to take precautions to avoid electrical shock. When installing a GFCI circuit breaker, follow the manufacturer's instructions carefully. Be sure to turn off the power to the main electrical panel before beginning any work. Identify the circuit breaker that you want to replace. Remove the old circuit breaker from the electrical panel. Connect the wires to the corresponding terminals on the GFCI circuit breaker. The wiring should match that of the old circuit breaker. Once the wiring is complete, carefully install the GFCI circuit breaker into the electrical panel. Secure the circuit breaker in place. Restore power to the main electrical panel and test the GFCI circuit breaker by pressing the test button. The GFCI circuit breaker should trip, indicating that it is functioning properly. If the GFCI circuit breaker does not trip, check the wiring and ensure that it is connected correctly. If you are not comfortable working with electricity, hire a qualified electrician to install the GFCI circuit breaker. Working with electricity can be dangerous, and it's important to take precautions to avoid electrical shock. There are several types of GFCIs available, each designed for specific applications. Firstly, receptacle type GFCIs are the most common type, designed to replace standard electrical outlets. Secondly, circuit breaker type GFCIs offer protection to the entire circuit and are installed in the electrical panel. Thirdly, portable GFCIs are designed for temporary use, like on construction sites. Fourthly, cord-connected GFCIs are integrated into the cord of an appliance or tool. The National Electrical Code, NEC, mandates GFCI protection in specific locations to mitigate the risk of electrical shock. Firstly, bathrooms require GFCI protection for all receptacles. Secondly, kitchens need GFCI protection for receptacles serving countertop surfaces. Thirdly, outdoor locations, where electrical equipment might be exposed to moisture, necessitate GFCI protection. Fourthly, laundry areas, given the presence of water and appliances, demand GFCI protection. Fifthly, garages require GFCI protection for receptacles. Sixthly, unfinished basements also fall under the GFCI protection requirements. Seventhly, boathouses and similar structures near water require GFCI protection. Understanding ground faults is crucial to appreciating the importance of GFCIs. A ground fault occurs when there is an unintentional electrical path between a live conductor and ground. This can happen when damaged insulation exposes a wire or when water creates a conductive path. GFCIs are designed to detect these faults and quickly cut off the power, preventing serious injuries. The sensitivity of a GFCI is a key factor in its effectiveness. GFCIs are designed to trip when they detect a current imbalance of 5 mA or more. This level of sensitivity ensures that the GFCI will trip quickly enough to prevent a dangerous electrical shock. Regular testing of GFCIs is essential to ensure they are functioning correctly. The test button on a GFCI simulates a ground fault, allowing you to verify that the device is tripping properly. It is recommended to test GFCIs monthly. If a GFCI fails to trip during testing, it should be replaced immediately. Grounding plays a vital role in electrical safety. A properly grounded electrical system provides a safe path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. GFCIs and grounding work together to provide comprehensive electrical safety. The combination of these safety measures minimizes the risk of electrical hazards. When selecting a GFCI, it's important to choose a product that meets industry standards and is certified by a reputable testing laboratory, such as Underwriters Laboratories. All certified GFCIs have been tested to ensure they meet specific performance and safety requirements. Installing GFCIs can significantly reduce the risk of electrical shock in homes and businesses. The cost of a GFCI is relatively low compared to the potential consequences of an electrical injury. By investing in GFCIs, you can protect yourself, your family, and your employees from electrical hazards. Maintaining GFCIs involves regular testing and prompt replacement if any issues are detected. Damaged or malfunctioning GFCIs should be replaced immediately to ensure continued protection. Ignoring these maintenance steps can compromise the effectiveness of the GFCI and increase the risk of electrical shock. When troubleshooting GFCI problems, there are several steps you can take to identify the cause of the issue. Firstly, check the wiring connections to ensure they are secure and properly connected. Secondly, test the GFCI using the test button to see if it trips. Thirdly, if the GFCI trips frequently, check for any ground faults in the circuit. Fourthly, if you suspect a faulty GFCI, replace it with a new one. If you are unable to resolve the issue, consult with a qualified electrician. Understanding the difference between GFCI and GFCI protection is essential. GFCI, or arc fault circuit interrupter protection, is designed to prevent fires caused by arcing faults. Arc faults can occur when damaged or worn wiring creates a spark, which can ignite nearby combustible materials. GFCIs are required in many locations throughout the building, including bedrooms, living rooms, and dining rooms. While GFCIs protect against electrical shock, GFCIs protect against fires. Both types of protection are important for electrical safety. When working with electricity, always follow safety precautions to avoid electrical shock. Firstly, turn off the power to the circuit before beginning any work. Secondly, use insulated tools to prevent contact with live wires. Thirdly, wear rubber gloves and safety glasses to protect yourself from electrical hazards. Fourthly, never work with electricity in wet or damp conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Educating others about electrical safety is crucial to preventing electrical accidents. Share your knowledge with family, friends, and colleagues to help them understand the risks of electricity and how to stay safe. Encourage them to install GFCIs and GFCIs in their homes and businesses and to follow safety precautions when working with electricity. By working together, we can create a safer environment for everyone. The technology behind GFCIs continues to evolve, with manufacturers developing new and improved devices that offer enhanced protection and features. These advancements include self-testing GFCIs, which automatically test themselves on a regular basis, and smart GFCIs, which can be monitored and controlled remotely. As technology advances, GFCIs will continue to play a vital role in electrical safety. GFCI protection is not a substitute for safe work practices. It is important to always follow safety precautions when working with electricity, even when GFCI protection is in place. By combining GFCI protection with safe work practices, you can minimize the risk of electrical shock. The NEC provides detailed guidelines for the installation and use of GFCIs. These guidelines are designed to ensure that GFCIs are installed correctly and provide the intended level of protection. It is important to consult the NEC when installing or maintaining GFCIs to ensure compliance with code requirements. GFCI protection is an essential component of a comprehensive electrical safety plan. By implementing a comprehensive plan that includes GFCI protection, grounding, and safe work practices, you can create a safe electrical environment for your home or business. Electrical safety is a shared responsibility. By working together, we can prevent electrical accidents and create a safer world for everyone. Staying informed about the latest electrical safety standards and technologies is crucial to maintaining a safe electrical environment. Attend training courses, read industry publications, and consult with qualified electricians to stay up to date on the latest developments.